In this video, we're going to talk about the basic concepts of organic chemistry, and we're going to be naming, representing, and using different types of formula like skeletal formula, displayed formula, and structural formula of organic compounds. This is part one of this section, and so there'll be part one and part two. In part one, we're going to talk about the basics in terms of naming and representing, and when we go to part two, we'll go into some more complex examples. So we start with carbon with the 4 electrons in the outer shell. Now, because it has 4 electrons in the outer shell, it can form 4 covalent bonds. So if we then look at this, we can see those 4 covalent bonds made in methane. So methane is CH4, and you can see these 4 hydrogens around the outside, and you can see these pairs of electrons here. And if you've done our bonding video, or you know bonding, you know you can draw these without the outer shell or with the outer shell in place. And what I mean by that is the circle, the line. So here we've drawn it without that line representing that shell, and we can see that there is 4 pairs of electrons. Now, one pair of electrons is one single bond. So we've got a single bond here, a single bond here, here, and here. So that is our carbon with our 4 covalent bonds. And you can see in the other way around, the hydrogen has one single bond coming up to the carbon. And it's really important throughout all of your organic chemistry, whether you go in your first or second year of your course, that you remember that carbon has 4 covalent bonds, that hydrogen has 1. It will save you so much time and get you so many questions right in organic chemistry. So we're going to start off by describing hydrocarbons. Now, it's a required definition, carbon and hydrogen only. And it's really important, and a lot of the mistakes I see when I'm marking papers is that it just says contains carbon and hydrogen. It's that only word that's really the difference. You must say carbon and hydrogen only. So we're going to go through some different types of hydrocarbons in this video. Now, most hydrocarbons are relatively unreactive, but they're reactive enough to be burnt and they're reactive enough to be used as fuels. But compared to a lot of other functional groups, which we'll talk about the term functional groups later, they are relatively unreactive. So let's talk about the first 3. And we're going to go through many during your course. And we can see that we've got alkanes, alkenes, arenes. Now you can say that arenes, doesn't really matter. And that's also known as aromatics. So we've got 3 different examples of these. This alkane, methane, hopefully you come across this in your GCSE or whatever qualification you did before you did your A-levels. And we've got ethene for an alkene, so the ene and the ene, the ane and the ane. And then we've got, and this will be totally new to everybody here, is that we've got benzene, which is an arene. Now, benzene is a very special molecule, which we'll do in detail later on in your course. But let's show you what they look like. Now, these 3 different types of hydrocarbons can be sorted into 2 categories. They can be saturated or they can be unsaturated. So our alkanes are saturated because they contain only single bonds. Our alkene is unsaturated because it contains a double bond. And our benzene also contains double bonds, so therefore that is unsaturated. But let's show you what they look like. So we'll go through our methane and just do a drawing of that to start off with. And again, there's nothing stopping you from stopping the video, trying to draw these different structures right now. I'm going to show you some slightly different types of methods of drawing these things. So we're going to start with the displayed formula. And that displayed formula is of methane. And that's just like the diagram we had at the start of the video. So we've got 4 different atoms, 4 hydrogens, 1 carbon, 4 single covalent bonds, and that means it is saturated. Now, we move on to our ethene. Now, ethene has a double bond in it. Okay, and there's our double bond. And again, this is where, remember I said every carbon has 4 bonds, or can make 4 bonds. It's really important there, can make 4 bonds, potentially. And then you look here and you go, right, how many bonds are missing? So we've got carbon with 2 bonds to it, So it needs a further 2 bonds, and those further 2 bonds must be the hydrogens. Again, 2 bonds to this carbon, a further 2 bonds must be the hydrogen. Okay. And again, just to remind you of things, you should have already done bond angles by now, and therefore, remember this is tetrahedral, 4 bonding pairs, and this is trigonal planar, 120. Now, let's move on to the next one, which is benzene, which will be totally new to people. So, benzene is in a hexagon. If I draw a hexagon like this, and this is my displayed formula. There's a hexagon in displayed formula. Displayed formula shows every single last bond, every single one. So, and it's got 6, you see it's 6 hydrogens there. So I'm going to put 6 hydrogens on, like that. And I also told you that it was unsaturated. So it's unsaturated, it has double bonds. Now, it has 3 double bonds. So 1 there, 1 there, and 1 there. And that's a pretty complicated, horrible looking diagram, okay? It's not very nice at all. So we don't draw benzene like this. We draw it in a much simpler way, which is skeletal formula, which we'll go over in a bit more detail later again in the video. But we're just going to draw the carbons, and we're going to know that we are an organic chemist who knows how many hydrogens are. We don't need to write them out. We know because we're clever organic chemists. So we look here, we go, right, let's just draw the carbons. And so there's a ring of carbons, and there's a ring. So I'm going to draw a ring, and every time there's a carbon, I'm going to change direction. So you can see where I've changed direction, or where 2 lines meet, you can see that's a carbon, that's a carbon, that's a carbon, that's a carbon, and there's 6 carbons in there. Okay, and now I'm going to put my double bonds in. So there's a double bond, there's a double bond, there's a double bond. And there's a tiny introduction to skeletal formula. And again, we'll go over that in a bit more detail later in the video. Now, you will also see benzene look a bit like this. So benzene will look, especially in your more advanced A level, it'll look like this. And that's because the electrons are delocalized. But again, do not worry about that right now. Okay, but they're the 3 ways in which you'll see benzene. You probably will never see this one. And these are our first 3 simple types of hydrocarbons. We're now going to look at homologous series. Now, homologous series is a series of organic compounds, and they have the same functional group. So we haven't really talked about functional group, but a functional group is a part of a molecule that gives rise to some form of chemical reactivity. So if you have the same functional group, it will react in the same way. It doesn't matter how long it is or how short the molecule is. So let's look at that definition again. A series of organic compounds, same functional group, but each member differing by a CH2. So what we're saying is that gets longer and longer and longer. So we have a functional group here, and then the chain gets longer and longer and longer and longer, or more complicated. Now that definition is in green because it is required. So make sure you remember it. Now those compounds are related to each other in that they have similar chemical properties. And those similar chemical properties are due to the fact they have the same functional group, but their physical properties vary because their size is varying, because they're getting larger and differing by that CH2. And we'll go over that in a little bit more detail as we consider our first functional group. So our first kind of homologous series is alkanes. So in alkanes, we know we've got methane. You see you've got methane here. It's got 1 carbon in, so N is equaling the number of carbons. And hopefully you've done it in your GCSE or whatever qualification you did. And you would have known that alkanes, as we said, are saturated, single bonds only. They have a general formula of CnH2n plus 2, and you can use that to find out whether something is an alkane. So here, our N is 1. 1 times 2 is 2, plus 2 is 4, and that's how we know there is 4 hydrogens there. So using this general formula, really important. So if you're sitting there right now watching this video, again, why don't you stop this video and try and work out all the molecular formulas from 1 through to 10. So the different alkanes end in ANE. So if it ends in ANE, you know it's an alkane. And you can start naming them, as we're starting to do here, by just putting that ane at the end and then having a prefix essentially that will tell you what is the number of carbons. So I have a mnemonic, which I use all the time, but you can make up any mnemonic you want. And my mnemonic lasts for about 7 of the carbons. I haven't got one for all of them, but it is monkeys eat proper big peanuts. And ha. So it is monkeys eat proper big peanuts, ha. That's because if you saw a monkey eating a proper big peanut, it would be quite funny. So, monkeys eat proper big peanuts, ha. So, monkeys eat, so that eat is standing for ethane. And then next one, proper. And then we go big, standing for bute. Peanuts, standing for pentane. And there's your ha, standing for hexane, and ha, standing for heptane. Now, if you do maths, most of these follow the kind of maths rules for shapes. Okay, most of them. So you can see here this hexagon, heptagon, pentagon, for example. It's only the earlier ones that don't quite fit with the maths. So you look as well here, looking at these different molecular formulas, you can see they go up by 1 each time for the carbon, and then if I times this number, the carbon, by 2 and add 2, I get the number of hydrogens. Now, in your A-level, you can see that you still need 3 more. So you will not be asked to name anything that is above 10 carbons. But you do need to remember up to 10. So I know the mnemonic goes to 7, but you've got to remember octane, nonane, and decane as 8, 9, and 10 carbons. So if you ever get asked to do anything, your teacher can ask you up to 10, and that includes decane. Next is shape of alkanes. So you know, hopefully, because you've done bond angles, and if you haven't, there's a bond angle video that you can watch, and please go back and do that. Pairs of electrons repel each other. That's called valence shell electron pair repulsion theory, or electron pair repulsion theory. And basically they repel each other so they're as far apart as possible. So let's talk about that in terms of alkanes and how you draw that in terms of its shape. Now alkanes all have 4 single bonds coming off each carbon, because it's an alkane, just saturated single bonds. So we have 3 types of ways in which we can draw them. We can draw one of them in front of the paper, one in the plane of the paper, and one behind the paper. So let's start. The first thing is draw the 2 of them in the plane. So it doesn't matter whether this is a long alkane and you have to draw more than 1 carbon, just follow the same process. 2 lines is always in the plane of the paper. So there you go, 2 lines. We then put one in front of the paper and one behind the paper. Now, if you look at this, you can see that this is getting fatter. So this wedge is getting fatter as it comes towards you. And that is a bit like if I'm far away like this, and then I come close, okay, I look like I'm getting bigger. So that looks like it's getting bigger, so it must be coming towards you. This one, the opposite, I'm dead close, then I get smaller. And you can see it's kind of getting smaller as it goes away. So that means it's going away from you. And that's a 3D, a shape of an alkane. Now, that shape is called tetrahedral and 109.5. So the difference between these pairs, the angle is 109.5. We're next going to talk about the structure of the alkanes. So our first alkane is methane, and you notice it says molecular formula, it now says displayed formula, and it says structural formula. So we're going to talk about what that means. So first of all, the molecular formula is the number of atoms of each type in the molecule. It's the simplest version. You just count the number of carbons, count the number of hydrogens, and then quote that. Now, the displayed formula is all the bonds being shown. And we can't really see the difference between all the formulas with methane. So let's go on to ethane. So if you look at ethane, you can see it's got 2 carbons. So we've drawn 2 carbons in a chain like that. That's how we start. And then we put the hydrogens in and making sure there's 4 bonds to each carbon, 1 bond from each hydrogen. Now we can start to see the difference between the molecular formula, which is just each element and how many of each element, how many of each type. Very simple. And then the structural formula. The structural formula, let's just try and get in this table here. Okay, so the structural formula, you can see here a CH3, and there's a CH3. So it tells you exactly what is on each carbon. What is going on each carbon? And you see there's 2 CH3s, so therefore the structural formula is 2 CH3s. If we go into propane, we can see that propane, simple again with the molecular formula C3H8, and we've drawn our 3 carbons in a row and then filled out the rest with hydrogens. And we've got a CH3, look at the middle carbon, it's a CH2, and then a CH3. And that's our structural formula. The next formula we're going to do is skeletal formula. Really, really important. And I've been teaching for a very long time, and I've gone through and taught thousands of students. I can honestly say that a lot of people find skeletal formula a little bit difficult at first. If you find it difficult at first, please persevere, because it will save you loads of time in the exam. Loads of time. And you're going to have to analyse it in the exam anyway. So it's worth persevering. Don't give up. Don't just, when you're asked to do something by a teacher, switch back to displayed formula every single time. Try and use skeletal formula. Now, skeletal formula doesn't show, as I said with benzene earlier, doesn't show the carbons, doesn't show the hydrogens, unless it's a specified group. So you can see here, there's an alcohol, which is ROH. I am showing that hydrogen on an alcohol because it shows that it's an alcohol. You also have to show the hydrogen on an aldehyde, which is the next one. And do not worry if you don't understand that right now. We're going to go through these functional groups in another video. So, at the end of each chain is a carbon, and there's a carbon each time 2 lines meet, or each time there's a change in direction. Now again, what does this mean? Well, let's make it make sense. So we have a set of rules, and we're going to do it with propane. So with propane, we know it's CH2, CH3, CH2, CH3. So we know we've got 3 carbons. So what you do is, you don't show the hydrogens, you just show the chain. So no carbons or hydrogens are shown, and there's a carbon at the end of the chain, and there is a carbon where 2 lines meet. Now, we can't tell where the 2 lines meet if we just draw it in a straight line. So what we do is we draw it in a bendy line. So we start here, and then go, there's 2 carbons, and then we change direction. There's 3 carbons. You might say, well, how do we get to that point? Well, we got to that point because let's imagine here, and I'm going to draw this in a slightly funny way. I'm going to draw the propane, and I'm going to draw it in this kind of like this V shape. And I've drawn it in that V shape. And now let's have a look at it and say, well, how did we turn this into this? Well, what we did is we said, right, okay, we are clever chemists. We're really clever chemists, so therefore we know how many hydrogens are there because we know there's 4 bonds to a carbon. So we just get rid of those because we know, because we're clever. Okay. Then we go from there, and we've got rid of all of those. Then we also say we don't show the carbons either. So the carbons are gone. Now those carbons are gone, and all we do is bond it back up again. But we need to be able to analyse this and say, look, okay, that's got there's 1 carbon there, there's 1 bond to it, so therefore there must be 3 hydrogens bonded to that carbon. There is 2 bonds to this carbon, so there must be 2 hydrogens bonded to it, and there is 1 bond to that carbon. There must be 3 hydrogens added to it because all carbons have 4 bonds. And that's our first example of how to do skeletal formula.